Electronics have advanced our daily lives in different ways, from your remote control to your smartphone and PC. But what's the first thing that comes to your mind when we talk about electronics? Maybe the circuit boards, and that makes sense, but the problem is that what if you want to measure your vital sign, your heart rate and pulse? So the rigid circuit boards don't seem to be the most comfortable thing because our body is soft, curvy and smooth, and here is when my research comes to the picture: flexible electronics. A new generation of electronics that are conformal with human body. I'm trying to develop electronics, especially sensors, as cheap and as durable and sensitive as possible using 3D printing. These sensors can be customized for each patient. To make flexible sensors, I use soft materials like rubber and make it conductive. But how can we make rubber conductive? We can use conductive nanopowders like graphene. Graphene is a nanopowder with excellent electrical properties. Let's go back to making flexible electronics. How can we use graphene to make rubber conductive? Maybe simply mix graphene with rubber polymer? I don't think that's the best way of doing it. When you mix rubber with graphene powder, the rubber would not be flexible anymore. On the other hand, 3D printing of rubbery materials is very time consuming and challenging, specifically in large scales. But what's the alternative approach? Instead, we use desktop 3D printers, plastic desktop 3D printers. These days, plastic desktop 3D printers are everywhere. They are very cheap and easy to work with. They simply melt plastic filament and make a plastic structure layer by layer. After having the plastic part, we coat a thin layer of graphene on the surface of plastic by multiple times dipping in a graphene solution and drying. Then we cast rubber polymer in it and let the silicone rubber to cure, and then we dissolve the plastic in a solvent. Interestingly, the graphene would transfer from plastic surface to a rubber surface and trap on its surface. Now we have a rubbery sensor that's conductive on its surface. These sensors are ultra flexible and durable. When you compress or stretch the sensor, since the graphene powder come in closer to each other or separate from each other, the electrical conductivity of the sensors would change. And by that, we can detect the information. We can even put these sensors in our shoe pad to detect our steps. The electrical signal will change if you change your speed or you start jogging or running. These sensors can also be used for detecting the vital signs or vibrations and for many other applications.